organizers for having me here. So I'm going to give some thoughts about construction and housing. As Professor Ashok said, a lot of my discussion will be on concrete. Construction is very, very important because it provides employment next to agriculture to the maximum number of people in our country, employs a lot of unskilled laborers who would not have any other jobs if not for construction. So these aspects have to be kept in mind. So what could be the goals for the future? Now, many people have talked about what India would be in 2047 in certain technologies. Construction may not be that different. If we look back at 50 years, 100 years, our spaces have not changed much, probably reduced. Some technologies have come in, but the way we live doesn't change that much. So what could be the things that we can aspire? What should we be doing towards 2047? First thing, I believe we should have faster mainstreaming of innovations. The construction sector has tremendous inertia. We think, we try and prove before we can use anything. So certainly we have to look at how we can make things come into mainstream technology faster. All civil engineering, including construction and all projects, are regulated by standards and codes. These standards and codes take a lot of time to develop, validate, put into practice. They take decades to change. Innovations cannot be introduced after the project design is finished. So a contractor who starts the work cannot come up in usual projects with innovations. Suppose somebody finds something amazing, they cannot, because the bill of quantities have been fixed, the specs have been fixed, and we cannot introduce changes at a later stage. Specifications are often repeated. Cutting and pasting specifications is the norm in construction projects. Nobody wants to be the first to use new stuff. Everyone wants the newest smartphone, but nobody wants the newest concrete because they don't know what will happen. Will it crack? Will it crush? Will it fail? So we have to be sure and sure before we use any technology in construction. So this becomes a tremendous impediment for mainstreaming of technologies. We need more emphasis on sustainability, as Professor Ashok said. Cement contributes 7% of the global carbon emissions. That's a lot. If we can just work on cement, we are working on 7% of the global carbon emissions. Stone, that is part of concrete, 5.5 billion tons alone in India are required every year. That means we are eating up mountains, we are digging up holes, we are making quarries on our Earth's crust. Tremendous amount of stone is used up. The building industry uses 30% of fresh water, 30% of effluents are coming from construction. So if we construct less, all these are going to be affected. Every time we demolish, now we've built up all our cities, there's no area available. We have to demolish. Where is it all going? If you've been involved in a project, if you've demolished something at home, where did it go? Somebody overnight takes it somewhere and dumps it. Right? And that is not our problem. But 700 million tons of construction and demolition waste is generated every year globally. So sustainability can have a major benefit if we work on construction. Thirdly, we need to have greater dependence on automation, prefabrication, and third-party control. We do things in a very ad hoc manner. We rely on manual labor. The laborer changes every day. If you know about construction projects, somebody takes a truck, goes slightly to a peri-urban area, brings people onto the truck, and those are the construction laborers that day. The next day, it will be a totally different set of people. This is how construction is done. We thought that we would have a lot of labor because of our population. But at every construction site, if you talk to the construction manager, they would complain that they don't have skilled laborers. They don't have good laborers. So labor is a very, very important thing. So can we prefabricate? Can we make things in the factory and bring them here? This building is a very good example. All the facade that you see is prefabricated. Lot of automation can be brought in when we do prefabrication. Can we bring in third-party control? Other countries do it. Here, we believe we should control. The administration, the owner believes that they should control. Can we bring in professional third-quality control auditors? So as I said, there is a severe shortage of manpower in spite of our population. Many construction projects are delayed and have cost overrun. It is said that 30 to 60% of money in a lot of public projects are siphoned off. Unethical practices can remove. Imagine you have budgeted for a certain project and immediately somebody takes that money off. What does it mean? Lower quality construction, poorer construction, less durability, cheaper materials being used. In construction, everybody has to be convinced about a new technology. There is no trust in the system. I remember once there was a building which sort of leaned in Coimbatore and they had to demolish it. The first thing the chief engineer said, thank God we did not use any innovation there. This was verbatim. We were at the meeting. So that is the amount of fear that people have for innovation in the construction. So let me take these three aspects and see if we can look at what can be done in future. In terms of mainstreaming of innovations, we need our structural design codes to be modified. Look at these numbers. United States brings out a structural design code every 3 years. The last one is 2019. Europe every 10 years. India, the last design code is from the year 2000. So that means no innovation that has happened in construction has gotten into our design code for the past 25 years. We are still waiting for a new design code. That means all construction in our country is being done now as we envisaged in 1995 when this code was written. New materials and technologies have to be adapted more easily. We have a very long process before a new material or technology can go in. Examples, fiber reinforced concrete, which is used a lot in warehouses. A lot of warehouses were made without proper design because we didn't have a code. Our first code took 20 years. 2010 was our first code that came out. The first code in other parts of the world was before 2000. Self-compacting concrete, a concrete that does not require energy for compaction. This building has been done with this technology, where we do not use any vibration. All the facades, you can see how the concrete is. No plastering at all, no cladding at all. But this is something that people fear. It could be done here because of IIT Madras. Because somebody said we'll put our neck out and we'll get it done. That could decrease the energy. High strength reinforcing steel, we are still using steel as per the specs of many, many years back. We can reduce our sections, we can use less material if we do all this. We should provide premiums for introducing innovations. Designers should be encouraged to innovate, not penalize them if they bring in something new. Contractors can be allowed to share savings. Can somebody come and say, we can build this cheaper, and we say, okay, we'll share the savings with you. Instead of saying that, no, that was the specification, that was the bill of quantities, those were the tender conditions, and you should not change anything. Can we have incentives for faster construction? So we talk about affordable construction. That for me is a misnomer. You cannot make anything cheaper. A lot of people in this audience may not know that concrete costs 2 rupees a kilogram. How can you make it cheaper? Mineral water is more expensive, common salt is more expensive. So affordable housing is not making it cheaper, making it faster, more durable, lasting longer. That is affordable housing. Not making concrete 10 paisa cheaper. So we have to look at incentives for faster construction. Can we give a contractor an incentive if he delivers faster? So these are things. More emphasis on sustainability. As we said, concrete and construction, we can work on. See, this is an example where we have here ordinary Portland cement. This is the cement we use a lot now. These are new cements. You see the carbon emissions, 850 kilograms of CO2 for every ton of cement. That is what we are emitting. We can bring it down. But lot of resistance, lot of reticence, because people think this is the pure cement. People want to use the pure cement. We won't use pure gold, but we want pure cement. We can do this. We can do this. In this building, we use fly ash. It was something new. People were afraid what will happen if you put it. But this building stands. So we can do this. There is technology available. We have to design for durability. We design for strength. We have to look at durability. Look at this. This is again the concrete we use today. This is the probability of corrosion. In 100 years, 95% probability of corrosion. I can bring it down if I use newer concrete. But we have hesitance. We have to recycle and reuse. All of our pavements can be made into new pavements using the same material. This is technology that we have. But again, we have the fear. What will happen? Will it work out properly? Can it be designed well? This is an idea we've come up with. Can we use solar energy to make concrete weak enough when we demolish so that we can crush it? So this happened because of an idea that we got from Professor Bhaskar Ramurthy. Then finally we proved it. It can be done. We take chunks of concrete for demolition, put concentrated solar energy, becomes weak, we crush it and we can use it, make new concrete out of it. So again, it can be done. Finally, automation. We can bring in ways of automation. This is the first 3D printed house on our campus. We can bring in robotics. We don't have to only look at manpower. Prefabrication. We can construct partially in the factory and then bring and assemble. Quality will be better, speed of construction and cost. Standardization. We have to make things more standard. Construction is very much ad hoc, and if we want to proceed, we have to tax, we have to penalize something that is non-standard and make it more and more standard. Thank you very much.